Welcome everyone to this Europe PMC API workshop. I'm Summer, the Europe PMC Community Outreach Officer, and I'll be chairing this session. I'll be adding links in the chat as we go along and monitoring the chat and the Q&A. It'd be helpful if everyone can add their questions for at the end of the session or at the end of each case study into the Q&A, so it's easier to keep track of where they are and they don't get lost between the links. And this workshop will be delivered today by Europe PMC's Senior Full Stack Developer, Zanara, and cover developer tools and APIs that we provide. Zanara will work through some case studies using the annotations API, and following that, you will get the opportunity to ask for specific examples or any questions that you have. So wonderful. I'll hand over to our speaker, Zanara. Thank you.
Hello, everybody. Welcome. My name is Zanara Shafiq. I am the Senior Software Developer in Europe PMC. I've been working with the team for over 4 years. And today I'm very excited to talk about our APIs that all of us work very hard to make it available to you all. This is for our agenda for today. First, I will start briefly start with the brief introduction to the content and APIs available in Europe PMC. Then we will move into annotation API, which is the focus of our discussion today. And then we will discuss use cases of annotation API in interactive manner. And we will be demonstrating these use cases on our live website. And also remember, this workshop is interactive, so please feel free to ask questions and participate in discussions throughout the session. We want this to be beneficial and engaging for you as much as possible. We have a dedicated Q&A session at the end. With that, let's start. Let me give you a brief introduction to Europe PMC content. Europe PMC is very rich in content, where we have 44 million abstracts from sources like PubMed, Agricola, and more. In addition to journal articles and books, we also have over 818,000 preprints from 32 preprint servers that we index. And we also have a full text article of 9.9 million and full text preprint for over 62,000. Because our content is complex in nature, due to which we have provided different ways for users to access data and filter it according to their needs. You can use article APIs to access data based on articles. If you are doing large-scale analysis or need manuscript files such as images or supplementary files, you might find bulk download more suitable. We also have grant and annotation databases, which have their own APIs for your own use. We also have a developer forum for users. If, for example, you have specific scenario in mind or are not sure which API or filter to use, you are always welcome to ask questions in our developer forum to get expert help. And in order to get answers quickly and are also get notified of our new releases and features, you should hit subscribe button. You can also contribute into Europe PMC by taking part in our open source projects and community. Here in this slide, I have shared the link for our open source project page. The link has also been shared by my colleague in the chat for your benefit. We are continuously making effort to make more of our projects open source so that everyone can benefit from it. Now it's time to talk about our annotation API, which is the main topic of our discussion today. But before getting into annotation API, I want to explain a bit more about the process that works behind the scene and make it possible for annotation API to provide annotations. We have developed a daily process, which we call text mining pipeline, which is the main process responsible for generating annotations. Now, annotation can have different or many definitions depending on the domain. What we call annotation is the tagging of biological concepts or relationship. For example, here you can see the chemical and protein concepts being tagged along with their context and the text positions. As you can see from the slides, biological concept doesn't have to be a single word. It can be different forms like longs and abbreviated, etc. So our text mining pipeline process consists of a set of sequential steps. These steps are fairly uniform while mining both full text and abstract. This includes section tagging, where we identify different sections such as introduction, abstract, etc. Then we proceed with splitting sentences of those sections. After that, we proceed with the tagging process by applying the dictionaries. These dictionaries are developed from database entries or ontologies. Here is the example of a disease dictionary. As I've explained that we have developed dictionaries, we have two types of dictionaries. One is based on controlled vocabulary, which is sort of mapping table with terms and corresponding IDs, as you can see in the example. Here, the different variation of inflammatory bowel disease have been mentioned, but with the different variations, there is corresponding single ID to those terms. And we also have expression-based dictionaries, which check for patterns. We use regular expression on those dictionaries, which try to match those regular expression in the text and map it accordingly. Our annotation link back to ontologies. Our dictionaries are open source, and the link in the slides and also shared by my colleague is available, where you can access or download those publicly available dictionaries. If here in the slides, you can see that the ontologies that we use based on different dictionaries. For example, for disease dictionaries, we use UMLS. For organism, we use NCBI taxonomy. For gene ontology, we use GO, and for gene protein, we use UniProt. I have already mentioned that we use expression-based dictionaries apart from these dictionaries as well, which just are regular expression-based dictionaries, and they try to match expressions in the text. On top of our dictionaries, we also follow a set of algorithms to remove false positive. These include basic operations like removing common English words, or also known as stop words. Example of stop words can be and, the, two common words in English. And to reduce noises, small words and symbols are also being removed. In this, I have to mention that accession numbers mining have an extra filtration step, because our tolerance for false positive when it comes to accession number is quite low. Hence, we have an additional step of validation for every tagged accession with its corresponding database. So we make API calls to check its validity, and it passes only if it's valid. Here I want to discuss anatomy of a typical annotation. Apart from tagging the concept, we also capture the text before and after of the concept to extract the context in its entirety. Similarly, in this example, prefix and postfix is extracting context of Mycobacterium tuberculosis. Prefix and postfix doesn't just give context, it also help identify the exact position of annotation in the text. Where exact match the concept, prefix and postfix summarize a few characteristics before and after in the same sentences. But there are always exceptions to the rules. For some annotations, due to some licensing restrictions, we are not allowed to expose the location and the context of the concept. So instead, we add frequency information to that concept in the given article, as showed in this slide. Instead of seeing the postfix and prefix, you're able to see frequency of that article. Now, as I've already explained how the backend process of the annotation API works, let's dive into some use cases. And from here, I will be navigating to our live website. So in order to go to annotation API page, you will simply go to our EuropePMC website, which is europmc.org. And on the main page, in the menu, if you go to Developers tab and click on Annotation API, you will land on our Annotation API page. Here are the main modules of Annotation APIs that we are going to discuss. But before that, I want to discuss few parameters that we are going to commonly use in our Annotation API. One called request limits, because our annotation, one article can have thousands annotations, and in order to reduce the load on our database, we have found a way to manage it by limiting the page size and applying the cursor mark approach. Based on this page size, one page will only contain not more than 8 articles. And in order to navigate through different pages, we have implemented cursor mark. I will be able to show you how you can use cursor mark to navigate through the pages in a minute when we go to our live website. Apart from page size and cursor marks, we also have another common parameter in all of our annotation APIs. We call it filter. Default value of filter is 1, but 1 means that whenever the filter is set to 1, it means that whenever annotation API will query any certain requirement from user, it will only query all the annotation matching that parameter. But if you want to also see the co-occurrences of your annotations, for example, if you have searched just the gene protein annotation, but you also want to see that all the other biological concept being tagged alongside gene annotation to find the co-occurrences, you will be just able to do it by setting the filter to 0. And as it's written in the slide, if you see when the filter value is 1 and I have searched the entity P53 with annotation API, it will give the result of all the articles that have mention of P53. But if I want to see that what other what other biological concepts have also been mentioned along in article 1, for example, alongside P53, I will just change the filter value to 0, and then with article 1 alongside P53, as you see in this slide, other biological concept will also come through annotation API. We also have annotation API send response in different formats. Here are the list of formats that annotation API send response in. The default is JSON, but you can also retrieve the response in XML or JSON LD or ID list format. Here are the modules that I've just showed you that we are going to discuss today. And let's, with that, just go to the website. So the first module we are going to discuss today is annotation by articles ID. As the name explains, user will be able to query all the annotations based on the articles they have. The first parameter for this module is articles IDs. It's a list type parameter, and it's required for this module. If you will read this description, it is describing what sort of format you should give your articles. The basic thing is that you have to give your source and colon external ID. Here are in detail what sources have what abbreviation that we use. For example, for PubMed Medline, we have to use MED. For PubMed Central, we can use PMC. And for patent, PAT, etc., you can choose you can see all the sources that we use and the abbreviation that you can use from this description. Let me give you an example. I am going to choose PubMed Central ID as an example. So I have this article ID where PMC is the source and colon, this is my external ID, and I want to extract all the annotation based on this article. For now, you can filter this result further down to type and subtype or section, etc. But for now, I'm gonna give it default value, and I will just try it out. For the sake of clarity, I am going to use this URL on the browser tab. So if you see, this is the result of our annotation API. Here are the common parameters, source, external ID, and PMC ID related to that article. And here is the list of annotation. It will give you a list of annotation for this article. And one object of this annotation is looking like this: prefix, postfix, exact, which is the exact concept, and the tag. This tag is summarizing the information of ontology. As I've mentioned earlier, that you can all of our annotations are linked back to ontology. In the tag parameter, you can see the link of ontology, and this ID is basically will navigate you back to the EuroPMC and highlighting this annotation on EuroPMC website. But I will not open it, but you can open it and then you will be able to see. And then we have the other information as type of this annotation, section, and provider, etc. One thing to mention is that this article, as I mentioned, that this is the list type parameter. So you can give it more than one articles. It receives maximum from between 1 to 8 values. So let's try to give it more than one. So here I have sort of used three different type of sources. I've used PubMed Central ID, I've used PubMed Medline, and I have used PPR ID. For now, I will just try it out without any other filtration. Let's see how the result will look like. If you see that, because I have given it three different articles, so it have returned me three different objects. Each contain one article's annotation. So this is the same PMC ID that I've given before, and I showed you annotation. This is the PPR one. You see all these annotations. I will open it, and it basically looks the same unless it's the licensing restriction article ID, which in our case it's not. So you can see prefix, postfix, exact, type, section, provider, etc. And it would be same in Medline one. You see, this was the Medline one. And here are the list of annotations that you can see. All the annotations been mentioned in this. Now, I've already showed you how you can use different values in articles ID. Let's try to filter this result further down. Now, I have this scenario that I want to see all the annotation in these articles, but I only want to see the those annotation of type gene protein, let's say. And for now, I don't have any other requirement of provider and section or subtype, but I can also narrow it down to further filtration. And I will try this result out. The first thing to mention is that you see that this PPR ID is returning empty annotation, which means that this PPR doesn't have any annotation of type gene protein, because we filter our result further to gene protein. But as I showed you earlier, this PPR had other annotations, but not have particular of type gene protein. But this PubMed Medline and PubMed Central ID does have annotation of gene protein. And let's see the result now. If you see the type, all of these types are gene protein now. And let's see the other one as well. See, this is also gene protein. All of this is gene protein now, because we filter it down to gene protein. You can do the same thing with section, subtype, or type. The subtype is only available for resource and accession number type. All the other dictionaries or the types doesn't have subtype. So that is how you can use our module annotation by article ID. This is for the specific case. If you know your article IDs, then you can just give your article IDs to annotation API, and it will bring you all the annotations, and then you can further filter it down to multiple use cases. Okay, our next module to discuss is annotation by entity. In this module, user can have specific scenario where they don't know their articles, but they do know that the entity they want to share, want to search, whichever articles it's been mentioned. So let's say I have an entity in mind, P53, and I want to see that all the articles that this annotation is been, this entity is been mentioned. So for now, I won't touch any of the other parameter, and I will just try it out. So now you see that this query have given me 4 articles result. All of this will have entity P53. See, this is P53. Let's try this. This is also P53. So this article, this particular article, this one had all of these annotation lists. It's about quite many, anyways. It's important to know that because the default page size was 4 here, that is why it only retrieved 4 articles per page. If I want to see that how many more pages are there, one thing to know that if this particular query had more than 1 page, you will always see the next cursor mark field have value other than 0. If it is other than 0, it means that this query have more pages. And in order to navigate to the next page, what I will do is I will have to use this cursor mark. So if you go back to your PMC and you see that this cursor mark parameter here, I will add this next cursor mark value in this parameter and query it again. This will retrieve the next page of the same query. And now you can see that this cursor mark value have also changed from 0. It means that this is the next page. And to in order to retrieve the next page, as in third page, you have to just change the cursor mark parameters value to this one. And that's how you will be able to navigate to the next page and the next page. But how would you know that this is the last page? Whenever the next cursor mark value and the cursor mark value will be same, it means that this is the last page. If the cursor mark is 0 and next cursor mark have some other value other than 0, it means this is the first page. If the request have only 1 page, which means that both next cursor mark and cursor mark field will have 0 value. So that is how, as I explained before, that we use page size and cursor mark approach. That is how we use this approach. Now, let's also try this filter parameter here. As I've already explained it, I will give you a live demo. So now you see this, I will navigate to, or maybe I'll just show you here. So with this filter equal 1, this result will only contain all the annotations of entity P53. If you will look into all of these, let's try some random annotations from here. All of these biological concept exact will be equal to P53. Because the filter is set to 1, it means that it have only retrieved all the annotations which is matching our exact requirement. But now I want to see that all the annotations that this article have other than P53, as in I want to see all the co-occurrences of other biological concepts with P53. In order to do that, instead of querying some other or using some other module, I will be able to use the same module with the same query. I just have to change the filter value to 0. I will do it here instead of going to website. And if you click it here, you will be able to see all the other biological concepts here now alongside P53. So first, see, this is all the other types. This is gene ontology. This is some other biological concept. This one is P53. So all the articles that have P53 at least one time, and then all the other biological concept alongside P53. This query will get all those articles, and you will be able to navigate through the pages in the same manner as I've explained before. So with this module, you can't filter it down to further parameters. You can only use either the specific entity or you can use the filter parameter. That is how you will be able to use our annotation by entity module. Our next module to use by user is annotation by provider. As the name explains itself, this is precisely to search all the annotations by provider. We in Europe PMC we have more than one providers. We use different other providers that can add their annotation in our system, and then that will be available to public through our annotation APIs. I will explain by the end of this session after the use cases how, if you have any annotations and you want to make it the part of our annotation system and want to be one of our provider, how you can do that. For now, if you are already a provider, if you know any provider in Europe PMC and you want to search the annotation specifically to that provider, you will be able to use this module, which is specifically created for that. It's called annotation by provider. For that, you have to select the provider that you are interested in from the dropdown. We have these many different providers with us. Let's select Intect for now. I'm interested to get all the annotations provided by Intect. And I will try it out. Here you see all the articles that have annotations provided by Intect. And again, because of the page size, it's only giving 4 articles per page. But if you see, this is the provider, and all of these annotation will be provided by Intect. All the annotation will have the same provider. There is one important thing to explain here, that this module also have filter parameter, but this in this module the filter parameter work in a slightly different way. Instead of finding the co-occurred biological entities, it actually find all the co-occurred providers, let's say. So let's say right now I have this requirement that I want to see all the providers, sorry, all the annotations provided by Intect, but I also want to see all the other providers that have provided the annotation for the same articles that Intect have provided. Sounds a bit complicated, but it will make sense in a minute. So for that, I will just use the filter 0 option and we'll try it out. Okay. So in this list now, you will be able to see all the annotations provided by Intect, but you will also be able to see all the annotation provided by other provider for the same article. So the first annotations will be provided by Intect, but if we scroll down a little and try to see, and now you see that all of these annotations also provided by Europe PMC are also appearing in this list. In this manner, filter parameter will work a little slightly different way than our other modules in this module. And the other thing is just you can use the different format. Apart from JSON, let's say I want to use ID list. How ID list will work is, instead of giving you the detail of annotations, I am just only interested in knowing all the articles that Intect have provided annotations for. I am not interested in the details of those annotations. So let's try this out with response JSON ID. So you see, instead of giving the annotation list, it's only providing me the details of these articles that have Intect annotations. If you're only interested to know which articles have Intect annotations, you can use this format. This is a use case for our annotation by provider module. Our next module is annotation by relationship. This one is a bit different than annotation by entity. With the module annotation by entity, you will be only able to search for the specific entity. And if you're interested in the relation or the co-occurrence of all the other biological concepts with that entity, you'll be able to use filter equal to 0. But there could be specific scenario where I am only interested to know the specific relationships between two entities. I don't want to know all the relationship with that one entity, but I just want to know that specific relationships. In that scenario, you will be able to use our annotation by relationship module, which have 2 required parameters called first entity and second entity. Let's say I'm interested to know the relationship between P53 with breast cancer. So I will search my first entity is P53. My second will be breast cancer. So here you will see the list of articles that have annotations list with all the relationship of P53 and breast cancer. If you see this exact is mentioning P53 and also breast cancer. This specific type of annotation is provided by open targets, which are specialized in relationships, but you will also be able to see all the entities which have just mentioning of P53 or breast cancer, but both of them have to be present in an article in order to be available in this list. Or if we want to see the specific example, we can navigate it to different pages, but it will take ages to do that, at least for me to demonstrate it to you guys. We can also again use the filter option again if you are certain with your result that yeah, I know that this relationship exists in this paper but or article, but I also want to know that all the other biological concept mentioned in this paper, then you can again use the filter parameter equal to 0, and then you'll be able to curate the same articles but with all the annotations that articles have available. And you can again use different formats in that to make it useful for your own use case. And in order to navigate it through different pages, you can use cursor mark approach. And this page size for our website's sake, we put it to default 4, but it can take maximum of 8 in number, which means that you can retrieve 8 articles per page. This is the use case of our annotation by relationship module. Our next module to discuss is annotation by section and or type, which is a bit extensive one. In this one, instead of giving it a specific article ID or specific entity, you just want to know all the annotations with the specific type. We have different types in annotation API, sorry. So here are all the annotation types that we have in our annotation API available. We have over 2 billion text bind annotation. We text bind both abstract and full text. We have journal articles and preprints, and we have annotations from all the EuroPMC and other groups as well. So in this module, you can see all of those 30 types of annotations in the list. And if you're interested to know all the annotations which have type gene protein, you will just be able to select it from the list. You can select all the different types, but I want to show you exact scenario where you have different subtype as well, where you can use subtype as well. So let's say I want to get all the annotation of accession number, but for the accession number, I am specifically interested in just let's say biomodels or let's say biomodels. I can further narrow it down to section, but for the sake of clarity, initially I will not change the section and I will just try it out. So you will be able to see all the annotations of type accession number of subtype models. That is how you, if you are only interested to know from section introduction or method, you will be able to further filter it down by adding a section filter in it as well. Rest of it is same as all the other modules. You can further it filter it down to with the filtration equal 0 to in order to get all the other biological concept or annotation in the same article. You'll be able to navigate through the pages or cursor mark approach, etc. I will quickly show you one example of, let's say, accession number of a database Go, and I only want to see it mentioning it abstract. I will just show you from here. that if you see all the other parameter of the annotation will be present, but it will only give you all the types, all the annotation of type accession number, of subtype gene ontology from section abstract. So you can use this module in a different variation. You can filter it down to further filtration. You can use one single filter or want to use all three filters all together. With that, we have summarized all of our use cases of annotation API. If you have any question, you can pop it into the chat.